Hello, we're into Unit 15. In this unit, I'm going to discuss one new symbolization topic, the topic of this video, symbolizing with a, an, and any. I'm also going to discuss universal derivation in the next video because QN are not enabled for the new problems you're going to be doing, and you need to use universal derivation to derive the QN theorems, the theorems that enable QN. The main topic of this unit, however, is going to be models and validity and invalidity, which are like truth tables, and so that will take a decent amount of explaining, so we'll get to those later. So as I said, in this video, we'll be symbolizing with a, and any. So let's consider a symbolization with the word using a as our determiner. So I say an electron has a negative charge, and if you read that in a textbook, that's a universal. It's saying that every electron has a negative charge. But you can certainly also symbolize when you see a it can be symbolized existentially, as in this case, a dog ate my homework. That's some x, dx, and ax is a natural symbolization. Both of these sentences are ambiguous grammatically, and the intended reading depends upon what the actual words mean, like what does electron mean, what does negative charge mean, what does dog mean, what does homework mean. It's because you know that electrons are a kind of thing. Having a negative charge is a just pretty generic property that you understand that the first one is universal and the second one is existential. But there are some cases where a, an, or any are not ambiguous but work in a kind of funny way. So consider this sentence: if any boy has a sister, there is a girl. So the symbolization of this seems pretty clear. It's some x, fx, and hx, then some x, gx. And so any here can be symbolized with an x, can be correctly symbolized with an existential inside the antecedent of the conditional. But what about this? If any boy has a sister, he is not alone. Well, we might try some x, if some x, fx, and gx, then hx, and that would be kind of like the previous symbolization. The only difference here is we have hx in the antecedent, in the consequent. Well, but now consider if any boy has a sister, he is not alone. So you might think, well, I'll symbolize this like we symbolized the previous sentence. So we had the any and the antecedent. We'll just symbolize the antecedent the same. So some x, fx, and gx, and then conditional, and then he is not alone, not ax. This is incorrect. The English, so consider the English, or the logical sentence and what that goes back to in English. It would be, if some boy has a sister, then that is not alone. Whether that is like a pointing, I say, what would you like for dessert? You're pointing a train, I like that. And then the person gives you the thing you pointed at. So the that here in the consequent has no connection with some boy. So that's not right. And in this logical sentence, we have a free variable, and we don't want free variables in our symbolizations for precisely this reason, that a free variable functions like a pronoun, but when we use variables in our symbolizations, they should always be bound. Because they're always being interpreted by reference to a quantifier. That x in the consequent is not interpreted by reference to the sum x, so it's not right. Well, maybe we could symbolize it with a universal instead. So for all x, if fx and gx, then not ax. But this has exactly the same problem as the previous sentence. The x in the consequent is still free, and so we still have, if every boy has a sister, then that is not alone. And that doesn't work either. So we need to do something else. What we need is a quantifier. When we go into the logical symbolization, we have to have a quantifier that has scope over the antecedent and the consequent. So if any boy has a sister, he is not alone. Well, we could say any boy who has a sister is not alone. Note we've gotten rid of the conditional now. And so every boy who has a sister is not alone. Well, we know how to symbolize that. That's for all x. If bx and hx, then not ax. So here we have the universal with scope over a conditional. So what's going on? So here, if any boy has a sister, there is a girl, the any boy gets symbolized as an existential inside the antecedent. Every boy who has a sister is not alone. That's a universal over a conditional. So this is confusing. We want to know when any is in the antecedent of a conditional, is it existential or is it universal? Well, it's both, actually. Sort of, though, depending upon the position. So this is the symbolization. So on the left we have some x, if some x, fx, and hx, then some x, gx. And on the right we have, for all x, if fx and hx, then some x, gx. These are equivalent. It's kind of weird, but that's what happens. When a quantifier moves in, so note that in both cases there are those variable, there's that x and the gx and the consequent, but it's bound by the sum x. So this x, the universal on the right hand side, does not bind anything in the consequent. So it can move into the antecedent or out of the antecedent, as long as in doing so it doesn't bind anything in the consequent. So if we think of it just the p like this, just meaning that the universal is not binding anything in the consequent, then this is how the universal confines in or out of an antecedent. Outside, when it's in the antecedent, it's an existential. When it's outside, it's a universal. And the opposite of the dual of this is also the case. So if we have the universal inside the antecedent, then it becomes an existential when it has scope over the whole conditional. Theorems, you can prove them. So example would be, each thing is such that if it is unhappy, then God is not good. If something is unhappy, then God is not good. So those are equivalent, right? Either way, if there's a thing that's unhappy, the conclusion follows, although the reasoning would go slightly differently in the two cases. So, if any, so if you have a sentence with an if any in it, and the key is the if any, it can always be correctly symbolized as a universal with scope over the conditional, even though the any occurs within the if clause. And if there are no free variables in the consequent bound by the universal, then the universal can be confined to the antecedent where it's an existential quantifier. Okay, so there's some a and sentences where they're not in the if, when they're not in an if clause. Then what do? Well, there may be a more natural, obvious reading, and if there is, then symbolize it that way. Or if you might be asked to give both existential and universal readings. We're not having exams in this class, but a homework might explicitly say to do that. But if you're not, then give the more natural reading. If you encounter if any, and the any binds, there's a pronoun in the consequent that's interpreted by reference to that any, then the any is symbolized as a universal over the conditional. If no variables in the consequent are bound by that universal, then you could put the universal into the antecedent, making the and thereby turning it into an existential. I'm going to close this lecture with a little bit about anaphoric pronouns and pronouns of laziness, two kinds of pronouns, one of which we've just seen. So we say if a boy has a sister, he is not alone. He is anaphoric on a boy. That means that it's interpreted by relation to a boy. Roughly, we're saying that the same thing, for the sentence to be true, it has to be the same thing that both has a sister and is alone. We can't say that he refers to the same thing as a boy, because a boy doesn't refer to any particular boy. It's a quantifier, and quantifiers don't refer to particular objects. But we can say that it's the same thing that has to be a boy, and such that anything that is both a boy and a sister, it's that very thing also has to be not alone for this sentence to be true. So that's that sort of same thing relationship there. That's anaphor. It's the same thing that has to do make different parts of the sentence true. So when a pronoun is working like that, it's anaphoric. And note that it does not introduce a new quantifier. It's not a new determiner phrase. We only have one quantifier when we symbolize this sentence. Okay. Now consider, if all boys have toys, they all are happy. So they all is what we call a pronoun of laziness. It's short for all boys. What the sentence is saying is, if all boys have toys, all boys are happy. So all boys here is not anaphoric. It's not that there's not some quantifier or determiner phrase that says, okay, all things or some things have a certain property, and then the pronoun helps to specify that property that they all have to have. It's doing this other thing. So the precise definition of an anaphoric pronoun versus a pronoun of laziness is a matter of linguistics, and that's not what we're doing in this course, and so we're not going to pursue the distinction more precisely. What you need to do is, and you have an understanding of how these different pronouns work, which is basically unconscious, and we're not going to try to sort of figure out what exactly that is. What's important is that you are in fact able to draw these distinctions in interpreting these sentences, and when you look at sentences for your homework, you're going to want to be able to draw this distinction and say, oh, is this a anaphoric pronoun and it means this, or a pronoun of laziness and means that? And if it's an anaphoric pronoun, it doesn't introduce a new quantifier, but if it's a pronoun of laziness, then it does, because it's really short for a new determiner phrase. So that's it for symbolization for this week. On to derivations and models.